Okay, 5.4 day 2, we're going to solve more radical equations and some equations with exponents. The strategy is the same, but these ones are going to be a little bit trickier. Okay, so I'm still going to isolate the radical on one side if possible. I'm going to raise each side of the equation to the power that matches the index. I'm going to solve, and then I'm going to check for extraneous solutions. Okay, so let's look at example 1. I want to isolate the radical, but there's actually two radicals. So I have this radical over here and this radical over here. They're each isolated on their own side, so I feel like this is good enough because at least I have the radicals on their own sides. Since it is a square root, I'm going to square both sides. Okay, this square root squared cancels, so I have 2x plus 5. The square root of x plus 7 squared is going to just be x plus 7. Okay, now I'm going to solve this just using my normal algebra skills. What do I think? I'm going to minus the x first. You could minus the 5 also. I leave that up to you. Now I'm going to minus the 5 now because I didn't do it yet. Okay, so I got x is 2. Okay, remember, radical equations can give us extraneous solutions. That is particularly true when there's like extra radicals. So let's do a quick little check. Okay, if I check it in the original, it's 2 times x plus 5. Does that equal to the square root of x plus 7? What is 2 times 2? 2 times 2 is 4. 4 plus 5 is 9. So square root of 9, square root of 9. They match. I could keep going and say it's 3 equals 3, but I can tell, once I can tell that it's correct, I'm going to just stop because my check is just to make sure my answer is valid. Okay, let's look at B. Okay, I want to isolate the radical, but again, there's two radicals. Okay, so I need to at least get one isolated. Well, this one's alone on the side. This one has the extra 3. If I divide by 3, I'm going to end up with the 3 over here, which is okay, except then I'm going to have a fraction, and I would rather not have a fraction. So since at least one side has an isolated radical, I'm going to square both sides. When I square the left side, I have to square the whole thing. Same on the right side. Okay, now I need to distribute the squared to this and to this. If I do 3 to the second power, I get 9. If I do the square root of x minus 2, the square root cancels, and I get x minus 2. I'm going to put it in parentheses because the radical canceled. Okay, the square root of 2x plus 3 squared is going to be 2x plus 3. Okay, once it looks like this, now I'm going to solve using my algebra skills. Okay, what should I do? I'm going to minus the 2x over. Okay, and then some of you are comfortable adding the 18 at the same time. 9x minus 2x is 7x. Cancel, cancel. 3 plus 18 is 21. Divide by 7, I get x equals 3. Okay, now I'm pretty confident in my math, but I do need to check to make sure it works because you never know. CK for check. Okay, on your check, I'm copying the original equation, so it's 3. Then it has a square root, and then it says x minus 2 equals the square root of 2x plus 3. And I'm just going far enough to figure out that this worked. 3 times the square root of 1 equals 6 plus 3. What is 3 times? 3 times 1 is the square root of 9. Yeah, that works. That's going to work. So my x equals 3 is a valid answer, and I'm going to move on. Okay, now C. Let's look at C. See the big space below C? That means this is going to be a good one. Okay, it says the square root of 9x minus 9 equals x plus 1. Okay, there's only one radical. It's right here. Is it isolated? It's isolated on the left side, so I can go ahead and square both sides. Okay, now on the left side, if I do the square root of 9x minus 9 squared, I get 9x minus 9. Okay, now on the right side, I have x plus 1 squared. There's no radical, so I have to actually multiply out x plus 1 times x plus 1. Now, if you can do x plus 1 squared in your head, I'm great with that. Am I gonna do it on the side? I'm gonna just do it right here. x plus 1 squared is actually x plus 1 times x plus 1, which is why I'm going to get a big mess. So I'm going to get x squared plus 1x plus 1x plus 1. Let me combine my like terms. X squared plus 2x plus 1. Okay, and if you skip from here to here because you remember the binomial square formula, that's fine with me. Okay, now we have to solve this equation. It has a squared in it, which means I'm thinking I need to do square root or factoring or something. Since it has an x term, I'm going to have to factor it. So I want it to equal 0. Since the x squared is already on the right side, I'm going to move this to the right side. Let me add the 9 too. Okay, so then this cancels, this cancels. So I get 0 equals x squared minus 7x plus 10. It's quadratic. I should get 2 answers. X has to times to 10, so 5 times 2. It has to add up to minus 7, so minus. So my answers are x equals 5 and x equals 2. Okay, that was already a lot of work. What do I have to do now? I have to check it. Especially on these type of problems, we're much more likely to get an extraneous solution. Okay, I'm checking them in the original. I have to check both answers. So let's just start with 5. So 9 times 5 minus 9 equals 9 plus, no, not 9 plus 1. What was x? 5 plus 1. Okay, 45 minus 9 is 36. Does 36 equal 6? It does. Okay, so this answer is totally good. Let's check x equals 2. Okay, so 9 times x minus 9 equals 2 plus 1. What is that? 18 minus 9 is 9. Is the square root of 9 3? Yes. So both of my answers happen to work here, but remember it is actually pretty uncommon for both answers to work. Okay, since that was tricky, we're going to do another one like that. If you feel confident, you can go ahead and mute me. Keep going. Okay, there's the radical. There's only one radical, and it is already isolated on the right side. Left side, I should say. So let me square both sides. Okay, on the left side, the square root and the squared cancel. Okay, now on the right side, x minus 4 squared, I actually have to multiply out x minus 4 times x minus 4. And some of you can times it in your head, and I'm okay with that. Some people like to times it on the side. I'm okay with that too. But I'm going to get x squared minus 4x plus 16. You could also do like a box on the side. If you do the box, you would do the box, and then you would write x squared minus 8x plus 16. Okay, since I have a squared, I'm going to have to probably factor it. Since the x squared is already on the right side, I'm going to move the things from the left to the right. So I'm going to minus the 2x. And I'm going to minus the 7. Let's get everything over. X squared minus 10x plus 9. Okay, let's see if we can factor this. Okay, to get 9, 3 times 3, but 3 plus 3 is 6. It must be 9 times 1. Minus. Okay, so my answers are x equals 9 and x equals 1. I'm going to check them in the original. Okay, so I'm going to go ahead and check 9 first. So what is that? 2 times 9 is 18 plus 7. 9 minus 4. 18 plus 7 is 25. That equals 5. Sure does. Okay, now let's check x equals 1. What is that? 2 times 1. 2 plus 7 equals 1 minus 4. The square root of 9 is negative 3? Not so much. Okay, so this answer doesn't work, even though I showed my work correctly and I solved it. I actually only get one answer. X equals 9 is the only valid answer. Okay, now let's try to solve an equation with a rational exponent. We know that rational exponents are actually the same as roots. Okay, so this is another strategy we could use. One, I'm going to isolate the term with the exponent. I'm going to reach each side of the equation to the reciprocal power, solve, check for extraneous solutions. Although the checking for extraneous solutions is really when it's an even root. That's the truth. Okay, so I'm going to isolate the term with the exponent. This is the term with the exponent. Okay, you don't need to rewrite it. I'm just rewriting it because I need a little more space when I write. Okay, so now step 2, I'm going to raise each side of the equation to the reciprocal power. So since this is to the 2/3, I'm going to raise it to the 3/2. If I do it on the left, I do it on the right. Okay, the reason we do reciprocal is the 3 cancels and the 2 cancels. Okay, so I get x equals 25 to the 3/2 is the square root of 25 to the 3rd. So x is 5 to the 3rd, which means x is 125. Okay. Okay, let's try one more no, there's a couple more like that. Okay, oh, I should check it. Should I check it? No. Okay, if I look at the bottom number here, it's a 3. I'm doing a 3rd root. If it's an odd root, you don't have to check it. If it's an even root, you do, but if it's odd, it should be fine. Okay, let me look at this. I want to isolate the part with the exponent. The part with the exponent is this whole thing. So it's already isolated. Okay, I'm rewriting it only because I write big. Okay, to cancel the 3/4, I'm going to raise the whole thing to the 4/3. I'm going to do the same on this side. Let's see, why do we do that? We do that because then the 3 cancels and the 4 cancels because we're multiplying the exponents. So I get x plus 2 equals the 3rd root of 8 to the 4th power. Okay, so x plus 2 equals, what's the 3rd root of 8? 2 to the 4th. So x plus 2 equals 16. And then I minus the 2 and I get 14. Okay, let's do a quick check on this. Okay, so if I put 14 plus 2 to the 3/4, should that equal 8? So what is that? That's 16. If I do the 4th root of 16 to the 3rd, is that 8? The 4th root of 16 is 2. 2 to the 3rd is 8. Yeah, that works. Okay, let's try one more. This will be the tricky one again. Okay, x plus 12 to the 1/2. Okay, the part with the exponent is isolated. Okay, since it's raised to the 1/2, I want to raise it to the reciprocal. So I'm going to raise it to the 2/1. Okay, the reason we do that again is because then the 2's cancel and the 1's cancel since we're multiplying. So x plus 12 equals, x to the 2nd is just x to the 2nd. Okay, since it's quadratic, and there's an x term, I'm going to try to factor it. Since the x squared is already on the right side, I'm going to move everything to the right side. So the x squared is going to stay where it is. To cancel the x, I'm going to minus it to the other side. To cancel the plus 12, I'm going to minus that to this side. Okay, now to get negative 12, what could I do? I could do negative 6 times 2, but that adds up to negative 4. Negative 4 and 3. Negative 4 plus 3 is negative 1. That works. So x is 4 and x is negative 3. I'm for sure going to check on this one because these type of problems are most likely to produce extraneous solutions. Okay, so 4 plus 12 to the 1/2. Does that equal to 4? Well, 4 plus 12 is 16. 1/2 is the square root of 16. Yeah, that works. Okay, now let's try negative 3. Okay, if I do negative 3 plus 12 to the 1/2, does that give me negative 3? Negative 3 plus 12 is 9. 1/2 is square root. Does that no, square roots give me positive answers. So this one does not work, but x equals 4 does work. So we got one answer, but we had to solve it out correctly to figure out that one of the answers did not work.